Welcome to The Explainer. Today, we're talking about something pretty fundamental. How do we get computers to think less like a calculator and a lot more like, well, us? We're going way beyond the simple world of ones and zeros to look at the kinds of AI logic that actually embrace uncertainty.
So let's just start with a really simple question that it turns out is incredibly tricky for a normal computer to handle. If I were to ask you right now, how would you describe the temperature outside? You might say, oh, it's warm, or kinda chilly, or maybe it's perfect t-shirt weather. But a computer, it just wants a number. And right there, that's the core of the problem, isn't it? A computer sees the world in black and white. It's all absolute, binary logic. A temperature is either hot or it's not hot. There's just no room for anything in between. But our reality, our whole human experience, is just full of these vague, subjective, and kind of fuzzy descriptions. You know, we live in the gray areas.
The truth is, the world we live in isn't some neat little set of true or false statements. It's messy, it's imprecise, and it's full of uncertainty. So the big question becomes, how in the world do we build AI that can actually handle the beautiful messiness of reality?
Well, the answer actually started taking shape more than 100 years ago, with a totally radical new way of thinking. It was a logic that dared to challenge the very idea of true and false by creating a little space for the word maybe.
So way back in the early 20th century, this Polish logician, Jan Łukasiewicz, he basically looked at the absolute binary of true and false and said, you know, this just isn't enough. He proposed a whole new system. It was the seed of an idea that would later get supercharged in 1965 by a guy named Lofty Zadeh, and his work is absolutely essential to the AI we have today.
What Łukasiewicz introduced is what we now call many-valued logic, or MVL for short, and it's a deceptively simple idea. Instead of just true and false, he proposed adding a third value, something you could call possible or undetermined. And with that one little addition, he cracked open the door for machines to start handling nuance and uncertainty in a really structured way.
Okay, so now let's take a look at how this idea grew into probably the most influential type of many-valued logic, the one that really lets machines think not just in black and white, but in, like, infinite shades of gray. And this brings us to fuzzy logic. This was developed by that researcher we mentioned a second ago, Lofty Zadeh, back in 1965. And its main goal wasn't just to add a third option like maybe. No, its goal was to mathematically capture that very human thing we call vagueness. The absolute core idea here, the thing that makes it all click, is something called a fuzzy set. Now, in old-school logic, an item is either in a set or it's not, right? You're either in the set of tall people or you're out. But a fuzzy set, it allows for a degree of membership. It's a value that can be anything between 0 and 1. Let's circle back to our temperature example. In a fuzzy set for the idea of warm, a temperature of 10 degrees Celsius would have a membership of 0. It's definitely not warm. 30 degrees would have a membership of 1. It's definitely warm. But what about 20 degrees? Well, it could have a membership of, say, 0.5. It's kind of warm. You can think of it like a dimmer switch for truth, instead of a simple on-off light switch.
And this is the real game changer. This concept lets AI finally understand and actually use what we call linguistic variables, all those subjective words that we use constantly without even thinking about it. And AI can now mathematically reason about concepts like tall, or fast, or warm, pretty much the same way we do.
So, okay, this is all really cool theory, right? But what does it actually mean for AI out there in the real world? How does this make our tech smarter, more helpful? What it means is that AI can finally get its hands dirty. Instead of needing perfect, clean data in some sterile lab environment, it finally has the tools to start working in the unpredictable, real world, where things are almost never clear-cut. And the applications are just massive. It's powering everything from AI that has to make decisions with incomplete information, to data analysis, all the way to expert systems that can finally make sense of imprecise, human-like rules. A fantastic example of this in action is a technique called soft clustering. So traditional data analysis basically forces every single piece of data into one box. You have to be in category A or category B, period. But fuzzy logic gets that in reality, things can belong to multiple categories all at the same time. I mean, think about movie genres, right? Take a movie like Shaun of the Dead. Is it a comedy, a romance, a horror movie? The real answer is, yeah, it's all of them.
With fuzzy clustering, we can say it has a really high degree of membership in the comedy set, maybe a medium degree in romance, and so on. It's just a much more realistic way to classify stuff.
And under the hood, there's some seriously powerful math making all this possible. Structures called MV algebras are the engine driving it all. You could almost think of it as a new type of probability theory, one that's built from the ground up to calculate the likelihood of vague, fuzzy events. It's the math that powers the maybe.
But believe me, this is not the end of the story, not by a long shot. The potential for thinking beyond true and false is now starting to unfold in some of the most cutting-edge areas of technology.
For instance, researchers right now are looking at how these very same ideas could apply to quantum computing. Instead of the normal binary qubits, which are 0 or 1, they're exploring qubits, which can exist in many states at once. The thinking is this could potentially unlock absolutely immense new levels of computational power.
And I think that brings us to the biggest takeaway here. By teaching machines to move beyond a simple true or false, we're not just building smarter AI. In a way, we're creating a kind of mirror. We're formalizing the logic of our own intuition. And in that process, well, we might just learn something really profound about the wonderfully uncertain way that we all think.